Okay, so we're going to have a look at the distance now between 2 points. We're trying to add in as many things as possible to our idea of straight lines and coordinate geometry. At the moment, we have found equations of lines. We've talked about if they're parallel, if they're perpendicular. We've talked about how slopey a line is, what its gradient is. Now we're interested in finding out the distance between 2 points in 2 dimensions like this. This is useful for many, many reasons. If you think about coordinates and knowing where 2 things are and how what their coordinates are, you might actually want to find out what the direct distance is between them. So, again, I think this is something that we maybe have seen before, perhaps from GCSE. Just a quick reminder that I've written at the top, this triangle, which is the capital letter for delta, it means the change in. So I've got this diagram, I've got 2 coordinates. I've got the coordinate 5, 9 and the coordinate 1, 6. And I want to find out the distance between these 2 things that I've got here. Just talk to the person next to you. Do you think you remember or do you think you know how you might find the distance between these 2 points? Okay, I'll give you 30 seconds to have a quick talk about that and give as much detail as possible. Okay, so what's the thing that's going to connect these things together then? What's the way of being able to find the distance? Pythagoras, okay. We are going to use Pythagoras because clearly here the thing we're looking for, the distance, is the hypotenuse of a right angled triangle, okay? The bit along the bottom is how much the x coordinate has changed, because the x coordinate is how far along you've gone. So how much, what is delta x? What is the change in x between here and here? 4, yeah, it's gone from a 1 to a 5, so the change in x is a 4. The change in y is how much it's risen up, and it's gone from a 6 to a 9, so it's a 3. So from Pythagoras, we can see that the distance is equal to, well, the distance squared is the change in x squared plus the change in y squared. So the distance is the square root of 4 squared plus 3 squared. What does that work out as? Good, it works out as 5. 16 plus 9 is 25, and the square root of that is 5. So here we have worked out that the distance between those 2 points is 5. To make this more general, we use this formula. Now, I wouldn't really think of this formula as being something new. This new formula is basically Pythagoras, okay? It is saying, find out how much the x coordinate has changed, which will tell you the bottom part of the triangle. It's then saying, find out how much the y coordinate has changed, which will give you the side part of the triangle. And then because we want the diagonal, the hypotenuse, you just square them, add them, and square root them. It is another application of Pythagoras. I think this is actually in GCSE. This is definitely something that you'll have seen in GCSE before as well. So we're going to go at these a little bit high speed. I'm going to do a few of these on the next page, and then you're going to do 3 of them for me as well. So you'll have noticed inside this bit here that I've put in the box, unlike with gradient, where it really mattered if, when we did the subtracting, the difference between them, it mattered if it was positive or negative, because it might mean that our gradient was positive or negative. Here, we don't really care whether they're a positive or a negative, because when you square a positive, you get a positive, and when you square a negative, you still get a positive. You get the same kind of result, whether it was -4 as your difference, or whether it was 4 as your difference. When you square it, you're going to get 16 both times. So we're just bothered about what the difference is between them. So the distance between these 2 points that we've got here will be the square root of the differences between the x. So we've got a 3 and a 5, which is just a 2 squared. And the differences between the y's, which is 4 and 7. So that's just going to be a 3 squared. So that becomes the square root of 4 plus 9, which is root 13. Okay? Notice how I'm not bothered about, oh, I need to do that one, take away that one, and that one, take away that one. It doesn't really matter because they're going to get squared anyway. For this second one that I've got here, I've got, for the x, the difference between 5 and 6 is 1, so that's 1 squared. And then I've got the difference between 1 and minus 3. Now, you could do 1 minus minus 3, which would give you 4. Or you could do minus 3 minus 1, which would give you minus 4. Notice how one way round gave you 4 and the other way round gave you minus 4. But I'm not bothered whether it's the plus 4 or the minus 4, because when I square it, it's still going to give me 16. So I'm just going to go with the 4 squared that I've got, which gives me the square root of 1 plus 16, which is the square root of 17. So the distance between those 2 points is the square root of 17. Again, for this last one that I've got here, have a look at the differences between the points that we've got. Nabil, what's the difference between the x coordinates? Minus 1, yeah, but actually I could just do it with 1 because I know that minus 1 squared is the same as 1 squared. Did you do the 0? Did you do the minus 1 take away the 0? We just, yeah, or you could do the 0 minus 1. Either way, you're going to get 1 squared or minus 1 squared, which will give you the same result. And what's the difference between minus 2 and 3? And when I say difference, I'm really talking about subtracting. Yeah, there's a gap of 5 between them. Minus 2 minus 3 is minus 5, or 3 minus minus 2 is 5. So I get the square root of 1 plus 25, which is root 26. So you've got 3 down here to work out. They shouldn't take you very long. I'll give you a minute to have a go at doing that. Why? Okay, I'll text that out. About 30 seconds left. Okay, that's been about a minute, so I'll give you just a little bit of time to finish off that last bit. Okay, these are obviously all integers. If they had fractional terms, you would still subtract them and square them. Okay, it's just because they're all integers. So, Ishraq, what's the bit that should be inside the... Good, so you've got 3 squared plus 4 squared, and that gives you 5. Good. This one that I have here, Ariful, what should be inside? 3 squared plus 2 squared, which gives you root 13. And this last one that I've got here, who's got onto the last one that can do it? Red one? Good, so you've got the difference between those is minus 8. I'm still going to just write it as 8 because we know it's going to give the same thing. And the difference is 6 squared. Pardon? 10. So that one comes to a root 100, which is 10. So sometimes you might get a nice answer like that as well. We're going to push on and just do the last part of this topic, and then we'll do a bit of practice to finish up. So, areas of shapes, we're going to do 2 pairs of examples, and then you're going to have a go, and then we're mostly finished with this topic. We've just got one small bit left to do. Okay, it says the diagram shows 2 lines with equations y equals 3x and x plus 2y equals 4, which intersect at the point P. You kind of know what's already going to happen for this bit, but we actually have done this question earlier on. If you can flick back through your booklet, we actually did this exact same question and we found out the coordinates of P. I wonder if you can find out where it is. How much was it? 4/7 and 12/7. Is that the right thing? Yeah, but it is that one. It's 12/7. Good. So we already did this a bit earlier on. So we now know that the coordinates of P are 12/7. Wanted to do that, you could just solve them simultaneously and the intersection point. It says here, the line 2y equals 4, the x-axis at the point, determine the area of the triangle OPQ. Okay, so find out the area of this triangle OPQ. Well, before you can even find the area of the, what needs to be done? Work out Q. Out this thing Q, we know that what Q is, so we should find what Q is. It's the x at the point Q. Selecting the x-axis, no, is 0. Okay, have a look at this. If y is 0, what is x? X equal to 4. Diagrams are really useful to start putting in onto the diagram. We know that Q, this point here, meeting is 4. I'm going to try and find, for the question now, area of the triangle OPQ. The triangle OPQ, area of the triangle that goes from O to P to Q and then to O again. I'm going to find the area of this we have inside here. Let's add a onto the diagram. First of all, P has an x of 4, 7. It has a y coordinate of 2 over 7. How do you find the area of a triangle? Divided by 2. Keep it simple. But the thing in height, the particular height of the triangle is. We've got the that is so that is 12 over 7. This triangle is 7. What's the triangle? 4. That's why it told us about the point Q. If we want to find the area of the triangle OQ, notice you draw instead of writing triangle. The triangle OP is the base to along in yellow is clearly 4 and the height is 7. Divide all of that by 2. Let's just do, that's the base. And then by 2. In fact, I really divide by 2, multiplying it by instead. Four times 7. 2. Can you do that in your head? Area is 4 over 7. The right centimeter, but the question is meters. We're just going to write over 7 squared because it squared. It could be squared. It could be millimeters. So we're just going to say it's 24 units. We together in practice, and I'll send you a bit of homework on this in the lesson. Well, okay. I know we're going quite fast. Okay, more on our shapes. We can hear of this line x plus 1, this line, which is 2 the length of P. Try and what this thing that to do. In order to find P and the Q, PQ, what else find? Find Q. And I find out what P is. So to find Q is, what do we know about when x equal to 0 for this we've got here? So y equals 4, so 1, 2. So 0, 2. Let's just there. Wants to write, think about so far. So the Q 2, so we that number. Think to yourself, I'm going to ask what they say. Do find in the picture. What do you find P? Do you think you find out of P? Very good, because I don't think it's these two perpendicular. No, it's really perpendicular in Q letter of P. So nice attempt, not perfect. How do you think that? A lot of people. So I wonder what do you define P? Good. This is and this solved. We have y equals x plus and we have x y 8. Professor solving this range. What do you want to x equals 8 y? Let's sub in and get equals 8 y plus. You see what we get? Okay. Because the coordinate P is 4. Add on that 4 2 0 2 and Q. We to each other. That means the Q. Q is it's between Q's between switch. It's 4 plus 2 root, which is 2 root 5. One thing this question, if I tell you all to find, probably if I want to EQ, do what that what you know with the Last thing, we're going to try the M, P, R. So we've Q and that I've box. Finding, trying an example in the question. One is you should choose the I area Q, which is Q like it's listed in here. Good as I need to think need to clarify. Got the P and the Q coordinate. Yeah, these so we can this is equal to R is x 0 y 0. Six divided by 2. Well, yeah. The next we've is exactly I knew what I'm referring to. Yeah, this is the base, the height of the person, right? From here, we P X and the coordinate is 2, coordinate 8, so that we've 6. So it's incredible here. I mean, it's really simple. So the of the P R rotate header is it's 90 degrees in 6 times 4 the half 12 is part to do normally they to each other this to talk question on the bottom of that page and then that will be us for today. There's been